Deep beneath the heavy soil lies a forgotten mechanical giant that time and nature have slowly claimed.
This massive iron heart stopped beating decades ago, and the earth has been swallowing it ever since.
Local scrap dealers saw only rusted junk worth $1,000 and walked away from the site.
But one determined engineer saw potential where others saw waste, and she refused to let history die.
The recovery mission begins immediately as heavy machinery carefully clears the dense clay from around the frame. Thick steel chains are secured to lifting points that have not felt tension in over 50 years. With a massive heave, the crane pulls the beast free from the grip of the wet earth.
The immense weight settles onto the transport trailer as the suspension groans under tons of solid iron.
It is a long journey to the restoration workshop where the real work is about to begin.
Arrival at the facility marks the start of a process that will test both patience and skill.
High-pressure water jets strip away the outer layers of caked mud to reveal the true condition.
Decades of soil wash away into the drain, revealing glimpses of the original industrial green paint underneath. She inspects the casting for fatal cracks that would render this entire restoration project impossible to finish.
Gallons of penetrating oil are applied to seize rusted bolts that have fused together over the years.
Extreme leverage is required to break the bond of rust holding the cylinder head bolts in place.
Not every bolt survives the extraction process, and broken studs will require precision drilling to remove later.
Pneumatic tools struggle against the corrosion, but slowly the remaining fasteners begin to back out of holes.
The massive cylinder head is lifted free, exposing the internal combustion chambers to air for the first time. The cylinders are filled with a toxic mixture of standing water and rust that has seized everything. Gravity helps remove the heavy oil pan, revealing thick black sludge that was once functioning lubrication oil.
She clears away the dense sludge by hand to reach the main bearing caps hidden deep inside.
The connecting rod bearings are completely destroyed, showing deep scores and wear down to the copper layer.
Brute force is necessary to drive the seized pistons out of the rusted liners one by one.
The first piston finally breaks free and drops from the block, carrying years of corrosion with it. Removing the heavy crankshaft requires careful coordination to avoid damaging the journals, which need precise machine work. The stripped block is submerged into a hot caustic tank to strip away every ounce of grease.
Chemical reactions work tirelessly over several days to dissolve paint and rust from the intricate iron casting.
Emerging from the tank, and the block is now bare metal and ready for the next crucial stage.
Abrasive blasting cleans out the deepest crevices, ensuring no rust remains to contaminate the fresh engine oil.
Precision instruments measure the cylinder walls to determine how much metal must be removed during the boring.
The boring machine cuts a perfect new surface into the cylinder walls, removing the damage from rust.
Fresh iron is revealed as the cutter spirals down, creating a perfectly round hole for new pistons.
Honing stones create a cross-hatch pattern that will hold oil and ensure the rings seal tight.
The crankshaft spins on the grinder while the operator carefully removes material to restore a smooth surface.
Final polishing brings the bearing surfaces to a mirror finish, which reduces friction and extends engine life.
Valve seats are cut to precise angles, ensuring that the combustion chamber is sealed tight against pressure. She laps the new valves by hand to verify the contact patch is perfect before final assembly.
Iron welding techniques are used to repair stress cracks in the manifold that formed from heat cycles. The welded area is ground smooth until the repair is invisible and the structural integrity is restored.
Fresh components arrive from suppliers tailored to fit the newly machined dimensions of the vintage engine block.
Final cleaning must be absolute, as even a single grain of sand could destroy the new bearings. Machined surfaces are carefully masked off to prevent paint from interfering with the tight mechanical tolerances later.
A vibrant coat of industrial enamel is applied to protect the iron and signal a new beginning.
Heat lamps cure the paint to a hard shell that will withstand oil and high operating temperatures.
The gleaming block returns to the stand, where the complex puzzle of reassembly will now take place.
New bearing shells are snapped into place and coated with a thick red lubricant for initial protection.
The refurbished crankshaft is lowered with extreme care onto the soft bearing surfaces to avoid any scratches. She follows a strict tightening sequence to ensure the crankshaft is held firmly but can still rotate. A simple hand test confirms the crankshaft spins freely, proving the alignment and clearances are spot on. Piston rings are carefully expanded and installed into the grooves without scratching the soft aluminum piston skirts.
Every ring gap is measured to prevent binding when the engine heats up and the metal expands.
Connecting rods are mated to the pistons with wrist pins, creating the reciprocating assemblies for the engine.
The ring compressor squeezes the rings tight, allowing the piston to slide gently into its new home.
From below, the connecting rod is guided onto the crankshaft journal, ensuring the bolts do not scratch.
Each connecting rod is secured to the crankshaft, completing the rotating assembly that drives the power output. The camshaft is inserted carefully into the block to control the precise timing of the intake valves.
Ear teeth are meshed perfectly, ensuring the timing marks align so the engine breathes at right moments. The oil pump is primed and installed to guarantee immediate oil pressure the moment the engine starts. A fresh gasket seals the bottom of the engine before the oil pan is bolted on permanently.
Verprost. The heavy block is flipped upright and the head gasket is...
The refurbished head is lowered onto the block, completing the core structure of the massive power plant. She tightens the head bolts from the center outward to spread the clamping force evenly across a gasket. Push rods connect the camshaft to the rockers, which will soon dance rhythmically with every rotation of engine.
Valve lash is adjusted to the finest tolerance to ensure the valves open and close efficiently later.
The valve cover is bolted down, sealing the top of the engine and hiding the complex mechanics.
The fuel injection pump is mounted and timed to deliver diesel at high pressure to the injectors. She bends new steel fuel lines to route them neatly around the block, avoiding heat and vibration. Restored injectors are seated into the head, ready to atomize fuel into the combustion chambers once again.
The heavy cast iron manifold is installed, followed by the turbocharger, which will force air into the cylinders.
On the opposite side, the intake manifold is secured to channel clean air into the vibrating engine. The massive flywheel is bolted to the crankshaft, storing the kinetic energy needed to keep momentum smooth.
A heavy-duty starter motor is aligned with the flywheel gear to provide the initial cranking power.
The cooling system is assembled with a new water pump to manage the immense heat this creates. Pulleys are aligned and the drive belt is tensioned to power the electrical system and cooling fan. A new wiring harness is fabricated and connected, ensuring power reaches the starter and the monitoring gauges. Restoration is complete, and the engine is moved from the assembly stand to the heavy test cradle.
Heavy bolts secure the engine mounts to the frame to prevent the torque from twisting the beast.
Gallons of fresh golden oil are poured into the sump, providing the lifeblood for the new bearings.
Coolant fills the water jackets and radiator, ensuring the temperature remains stable during the first critical run.
She hand primes the fuel system to bleed out air bubbles that could prevent the injectors firing.
Heavy-gauge battery cables are connected, completing the circuit and bringing potential energy to the starter motor.
A final visual inspection confirms every bolt is tight and every hose is clamped before the test.
The moment of truth arrives as her hand reaches for the start button to wake the giant.
The starter motor engages, and the heavy internal components begin to rotate for the first time alone.
As the engine cranks, the oil pressure gauge climbs, proving the lubrication system is priming the bearings.
Puffs of white smoke emerge from the exhaust stack as the cylinders begin to build compression heat.
She adjusts the throttle position slightly to introduce more fuel into the chambers and encourage the ignition.
The engine catches briefly and fires on a few cylinders before stumbling as the air clears out. On the second attempt, the cranking speed is faster and the smoke turns darker, indicating good fuel.
Suddenly, the machine roars to life and settles into a heavy rhythmic idle that shakes the floor.
Vibrations run through the test stand as the engineer watches her hard work thundering in front of her.
She scans the block with a flashlight looking for leaks, but the seals hold the pressure perfectly.
Opening the throttle increases the RPM, and the turbocharger whistle joins the mechanical symphony of the pistons.
Gauges indicate that temperature and oil pressure are holding steady, right in the center of safe zones.
The front accessories spin in a perfect blur driven by the power generated deep within the block. The exhaust clears completely, leaving only heat waves as the rings seat, and combustion becomes clean, efficient.
She places a hand on the vibrating valve cover, connecting physically with the machine she brought back. The workshop is filled with the sound of success, proving that this buried engine was never scrap.